Okay, here we've got question 1 on the 2020 exam. So this is a Boolean logic problem. It says we're developing a logic circuit to determine whether a basketball player can score more than 2 points on a given play. And it provides some rules here on when you can score more than 2 points based on a few variables. And so we're going to have a few variables here, mainly being a equals 1 if the ball is shot from outside the 3-point line. B is 1 if the ball goes in the basket. C is 1 if the player is fouled on the shot. So we're going to have a truth table with A, B, and C here. So those are our inputs, and then we're going to have an output, which is going to be whether or not we can score. That's Z is the output we have here. So we're going to write out all of our potential inputs. That's 0, 0, 0, 0, 1, 1, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1, and then 0, 1, 0, 1, 0, 1, 0, 1. Okay, and so A is if the ball is shot from outside the 3-point line. And we're basically given the conditions here when this is true. So if the player shoots from outside the 3-point line and the ball goes in the basket, if that's the case, then you always can score 3 points. So that's A is shot outside the 3-point line, B is the ball goes in the basket. So you can score if you shoot from outside 3 and it goes in. Next up, we shoot the ball from outside the 3-point line and the ball does not go in, and the player is fouled on that shot. Then you have a chance. And so C is that you are fouled on the shot. B is if it goes in the basket. So here we're looking for you shoot from outside the 3-point line. That's A is 1. Doesn't go in the basket. And C is you're fouled on the shot. So in this case, you can make it. In this case, you cannot because you shoot, it doesn't go in, you're not fouled. That's just no points. So done. And then finally, you shoot from outside the 3-point line and the ball goes in the basket and the player is fouled on the shot. Well, we actually already have that one because that was part of this condition. So you shoot from outside the 3-point line, the ball goes in and you're fouled on the shot. Let's just check if any of the other ones matter here. So we have doesn't shoot from outside the 3-point line, the ball goes in, and then you're fouled on the shot. So that's actually another case that this works in because we shoot from inside the 3-point line. Oh, that's the last condition here. I misread that. We shoot from inside the 3-point line. So A is 0. The ball goes in, and you're fouled on the shot. So this is the last case we have. This one is we shoot from inside. The ball goes in, but you're not fouled. So that's just 2 points. No chance at 3. Here you're fouled. The ball doesn't go in, so that's chance at 2 points, but not. And here you're not fouled. You're not inside the 3-point line. The ball doesn't go in, so you just completely missed, and that's a 0 as well. So that's our truth table. These are the cases. Again, it's just described in English up here, and we're given the variables. We're just following those variables and understanding what happens there. Next, we need to draw a logic gate circuit that we could implement from this truth table using and or not gates. And so here we need to first do the sum of products. So we need to figure out what Z is. And there, again, we're looking at all of the rows in which we have a 1 as the output. And we're just using the variables that came into that. So here we had A naught and B and C, and that caused Z to be 1. So if A is not true, B is true, and C is true, Z is true. Or we have that A is true, B is not true, C is true. So A, B naught, C, plus A, B, C naught, plus A, B, C. Before I draw a logic gate, and by the way, this is not worth 4 points, this question in general. I would save this for the end if you're working on a test that has this type of a question, because this is a very involved question for 4 points of your total score. But let's reduce this a little bit. We can see here that C is common between these two terms, so we can have C and A naught B or A B naught. So if you're fouled and you're either inside the line and it goes in, or you're fouled and it's outside the line and it doesn't go in, you have a chance. Or in these two terms, we have both AB with C or C naught. So C doesn't actually matter. If we can write that out if you want, which is C naught or C. We basically pulled the AB out of that, and then we have either of those terms. And true or not true is just going to kind of cancel out, so we can get rid of that. And that leaves us with C and A naught B or AB naught and AB. So this is going to make it a little simpler for us to be able to draw this out. So let's have our A here and our B here. We're going to have, each input coming into this, and then C. And let's go ahead and do the AB part of this first. So if we've got A and we're going to jump up here with B. We've got A and B. That coming out of there is AB as our output. Keep in mind here, we just need to know what these gates look like. It's not that big of a deal otherwise, but we've got AB coming out now. We've got to also get A naught B and A B naught. So let's go ahead and pass. We'll sort of jump over here with A. We'll pass it through a NOT gate to get A naught. And we'll have to do the same thing with B. So we'll have A naught there. Let's go ahead and take B's value from here. Just ignore that. And let's pass that along. And this is going to give us A naught B coming out of there. And then we also need to be able to get A B naught. So I'm actually just going to, let's go ahead and extend this up like this. And we'll draw it out here. And we'll take B's value. And this is going to be horrible. But let's just go ahead and we'll jump that up there. Jump that up there. And pass it along. And here we've got, we need to have a NOT coming into this. So this is why this problem is not worth it. It's way too much work. And there we've got now A, B naught coming out of that. So now we've got all the A-B combinations that we might need. We're going to have to be a little messy here. C, it looks like the only thing we need C for is to combine it with A, B, or A naught B. So let's take these two that we had. Yeah, I definitely did this in a bad way because now I got to combine these two. So let's go ahead and just bring this one down here. And then we're going to put that into an OR gate this time. And that's going to be now A naught B or A B naught. Is what's coming out of that OR gate. And we've got to combine that with an AND with C. So we'll just bring that up over there. And that's our C or C and A naught B plus A B naught. That's what we're coming out of that input. And then the other one we had there is just the AB, so we need to just get this out of there somehow. We're just going to pull that along. This is our AB line coming in here. And we're combining these two into an OR gate, so let's just go ahead and bring it down here so we don't have to draw a huge OR gate. And that is our output Z. So again, it's complex. You can see another solution in the notes there. I did not a great job of sort of drawing this out logically since I skipped over some lines, but really the idea is to just get each subterm by using the gates that we need to get that subterm, and then continue on from there until you've combined them into the entire expression Z that we're looking for at the end. Okay, so let's move on to question number 2. Then, and here we have determined V out in the transistor circuit to the right for the combination of inputs. So first we have VA equals 0, VB equals 5, VC equals 0. The important thing to remember is if we have a positive value coming in here, so logic 1 or a positive voltage, so high voltage, so 5, we're going to draw a wire. If we don't, we're going to draw a gap. So if VA is 0, we have a gap there. VB is 5, so we don't have a gap there. VC is 0, so we have a gap there. And really, we just see that we don't have a connection from our input 5 volts to the output ground. So in this case, V out is going to be 5 volts because there's nowhere else for that to go. It can't get out of the ground, so it's going to go out of the V out basically here. So that's all we're seeing with this one. The first question, we can't get there. Here we have VA equals 5, VB equals 5, VC equals 5. So in that case, VA is a wire, VB is a wire, and VC is a wire. And that means we have a wire the whole way to the ground from our 5 volts. That means that our V out is going to be the less attractive option, and we're going to go to the ground instead, which means V out is going to be 0 volts here. So that's it for that one. Really, it's just the idea is that if the input coming into the transistor is on, if it's the high voltage value, then it becomes a wire in our drawing, and we just basically eliminate the transistor, draw a wire there. If it isn't provided a voltage, if it's a logic 0, then it becomes a gap in the circuit, and so then we just leave a gap there where the transistor used to be, and that means that it can't pass through that part of the circuit diagram. That's it for 1 and 2.